Let X be the random variable with the P and F here. First, determine the value of C. We know the property of the random variable, or the property of the PMF is I add all the PMF together, then there will be 1, which means if I add all PMF, it should be 1. That means k is from 1 to infinity. pk is c divided by 2 to the k, should be 1. So now take the c outside, and the summation is 1 divided by 2 to the k. So it's 1 plus 1 over 2 plus 1 over 2 to the 2 to the infinity. Should be 1. When k equals 1, so there's here. So I can take c over 2 outside. It's 1 plus 1 over 2 plus 1 over 2 to the 2 is 1. And this summation is 1 over 1 minus 1/2. So finally, c equals 1. Part B, find the probability of x greater than 4. Probability of x greater than 4 is probability 5, probability x equals 5, 6, 7, 8 to the infinity. And we can think that in another way around is I can have like 1 minus the probability of x is less than equal to 4. Then this one is easier to calculate, which means 1 minus probability of x equals 1 minus probability of x equals 2 minus probability of x equals 3 minus probability of x equals 4, which means 1 minus 1 divided by 2 minus 1/4 minus 1/8 minus 1/16, which is 1/16. And the probability of x between 6 and 8 will be the probability of x equals 6, since it's discrete. So we can add those 3 probabilities, x equals 7 and x equals 8. Then you can find the final answer is 7 divided by 2, 56. Now we need to find the expectation. The expectation is the summation or the possible outcomes times the weighting. Which means k from 1 to infinity, k times 1/2 to the k, since c equals 1. So I can take 1/2 outside, and the summation k equals 1. To infinity, and here's k and k minus 1. The power is k minus 1. And this, from the homework 1, it is 1 divided by 1 minus 1/2 to the square. So the final answer is 2. You can see the videos for the homework 1 how we calculate this. Now we just omit the process of calculating this summation. Now we want to find the variance of x. The variance of x is the expectation of x squared minus the expectations x to the 2. So we need to find the expectation of x squared. So now the expectation x to the square is the all possible function of outcomes times the weighting, which means k from 1 to infinity, k squared 1 over 2 to the k. And here is 1 over 2 to the square. Take this outside. Then we have summation k from 1 to infinity, k squared 1 over 2 to the k minus 2. And here, this one is 1 over 4th. This summation, we can have 2 summations to represent this summation, which is summation k minus 1 1/2 k minus 2 k from 1 to infinity. Here is k squared minus k, so I have to add the k back. K from 1 to infinity. This one, k squared equals k minus 1 plus k. We use this trick for some reason, and we will see that in the next line. Because this summation is from homework 1. We take the second derivative of the summation from k equals 1 to infinity, the ratio to the k, and the ratio is 1 over 2. From homework 1, you will see how and why it is then we need to take the second derivatives. And for here, for this part, we take another 1/2. We take 2 out, so there'll be 1/2. Since we take 2 outside, here I will have only k minus 1. And k is from 1 to infinity. We take 2 outside because this is this dimension. This dimension is the same as here. There's a typo. No. This dimension is here. Which is 4. So finally we will get the first summation here. The ratio is 1/2, and the second term is 2. We can get the answer is 6. Please check the previous videos for calculating the summation about this term if you don't understand. So finally the variance is 6 minus 4. Then the answer is 2.